Here's a final question from homework number 11. It says, in a state pick 3 lottery game, you win $1.49 to select a sequence, or you pay $1.49 to select a sequence of 3 digits from 0 to 9, such as 477. So we can see that repeats are allowed here. If you select the same sequence of 3 digits that are drawn, you win. If you win, you collect $368.36. All right. The first question is asked, how many different lottery sequences can you choose? All right. Well, whenever we have something like this, we have to consider our 4 possible options. Is it an exponent, n to the r? Is it a factorial question? Is it an n choose r or an n the r? Well, in this case, we know it's this one right here because all of these involve the factorials, which tell us we do not have replacement. We can't reuse numbers. So therefore, this must be n to the r. And just quickly, because it's only 3 digits, just a reminder. This means, for example, we have 10 digits to choose from, 0 to 9. We can choose any of those 10 digits for our first number. But we can choose any of those 10 digits as well for our second and our third, because we are allowed repeats. So that's another way of writing that is 10 to the third power, which is 1,000. Okay, and part B asks us, what is the probability of winning? Okay, well, we know the probability of any event is the number of successes over the total outcomes. Well, there's only one winning lottery ticket, and out of the possible 1,000. So your probability of winning as a decimal is 0.001. All right. Part C asks, what is your net profit? So that means if you win, how much money will you have gained? Well, you know that if you win, you're going to win $368.36. However, you did have to pay out $1.49. So if you do that on your calculator, you will get $366.87 is your net profit. That's what you end up with. All right. The last question here is the most challenging. That's going to ask us, what is the expected value? Okay, expected value. And we talked a little bit about this in class. Expected value is really just what is the mean. It is the same thing as the sum of x times the probability of x, right? And that's the same thing as the mean. So it is, in other words, we're going to have to find a probability distribution. We're going to have to create our own little probability distribution to find that expected value. And so let's do that. This is a probability distribution with just 2 possible outcomes. All right. In fact, the only x's we can have are either a win or a lose, right? And x in this case is not a discrete random variable, so this is sort of a modified probability distribution, but it's the amount of money that we're talking about here. So for a win, another color here so you can see this. For a win, we have, if you win, you are going to win $368.36. If you lose, you are going to lose $1, and we'll call that negative because that indicates a loss, $1.49. So these are the 2 possible things that can happen. If you win, you get $368.36. If you lose, you're out $1.49. All right, the probability of this happening is back up here. The probability of a win is 0.001. Now, we didn't talk about this before, but the probability of a loss is just the complement of the probability of a win. So it's going to be the remaining 999 possibilities out of 1,000, all those other combinations. So the other way of writing that as a decimal is 0.999. So down here it's 0.999. That's the probability of losing. All right, so let's go back. Let's create that third column now of our probability distribution, where we find x times p of x. And I'll let your calculators do that, but you can multiply these 368.36 times 0.001, or you may just notice it moves the decimal point a couple places to the left, 36836. I'm just going to carry it out for now. And then if you do this on your calculator, negative 1.49 times 0.999, you're going to get minus 1.48851. Okay, this means sum of. We have to sum up this column. So we're going to put a line here. And if you do this on your calculator and you add these two numbers together, you're going to get a net sum of negative $1.12. That is your expected loss in this case. Now, that doesn't mean if you played the lottery once, you're going to lose $1.12. It means if you play the lottery over and 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 over again, you are going to have, you're going to get closer and closer to this net result. You're going to lose and lose and lose and lose, and you're going to keep losing this amount of money. And then you may win. 1 in 1,000 chances you'll win. But over time, as you continue to lose, your net and expected loss is going to be $1.12. So that gain is to the house, and that's why lotteries make a lot of money and gambling casinos make a lot of money. So give that one a try. I apologize. I realize I made a mistake here. I don't really want to redo the whole video because the end result is the same. I put the wrong number in here. This value should be the net. I apologize for that. This should actually be the $366.87. That's what you gain if you win. The probability of x stays the same. This will be slightly different. This will now be 0.36687. However, when you plug it into your calculator, you will discover, because it's just such a small change to the thousandth place, that your net result is still the same. Okay, apologize for that mistake.